This is William Kimberley from Racetech Television. I'm here at Williams Formula 1 talking to Kirsty Andrew, Head of Commercial Operations at Williams Advanced Engineering. Now, we all know about Williams Formula 1. They've just celebrated 600 races in Formula 1, but we know less about the advanced engineering aspect. So perhaps, Kirsty, you can tell us a little bit about it, please.
Well, William, advanced engineering was created in order that we could develop business streams for our intellectual property, our know-how, and the abilities that we have developed in the Formula 1 side. And one of the reasons for that is because the FIA have pursued an energy efficiency agenda, so a lot of the technology we've developed to go racing in Formula 1 has a much wider application.
Right. So that really means things like energy storage systems, Kirsty?
Exactly. So the kinetic energy recovery system on a Formula 1 car is actually the hybridisation of a Formula 1 car. And I think perhaps that would be useful terminology for us to use in Formula 1 to help the general public understand how we're transferring technology into other industries. Now, we're doing it directly because we are the only F1 team currently who develops the entire system itself. So the battery management system, the inverter and the motor generator unit are all designed, made and developed in-house.
Well, that's really a substantial amount of engineering going on here then. So typically, who are your customers?
Some other race teams. Obviously, you've seen the flywheel being used by the Porsche in the 911 GT3R, by Audi in the e-tron, which won Le Mans this year and the previous year. So motorsport's an obvious crossover for that sort of technology. But also, we're starting to do programs where we're putting our systems into more mainstream and mass transit applications like buses and trams.
That's interesting. I also saw you on BBC television last week where you were doing trains as well. Alstom, I believe, are sort of learning from your processes and your engineering. Is that correct?
Yes, well, with Alstom, what we've actually been focusing on is the flywheel, actually, is to make it energy efficient. Because in situations like the bus, for example, you can save 20% of fuel, which is a direct 20% emission saving. And that's something that in urban environments, people are becoming more concerned about because air quality is pretty poor.
And also, I was reading that this flywheel methodology is also perhaps going to be introduced onto railway stations, so it can perhaps capture the energy as a train comes into the platform. Is that correct? Yes,
that's an application that's being looked at because it would stand at the platform side. Obviously, it needs to be an electrified rail system, and as the train comes into the station, it will, as it brakes, rather than burning off the energy through resistors, which is what happens at the moment, you capture the energy electrically and store it mechanically in the flywheel at the side of the railway station. And then similarly, when you move away from the station, that energy is transferred back from mechanical energy to electrical energy and used by the train, and that saves fuel.
That's extraordinary. I bet not many people know that, really. Are there other applications that could be used for as well? Buses or something?
Yes, certainly for the static one is a larger scale problem. So something like an underground train would be quite a good application because, again, as you're braking, you're burning off the energy via heat through the resistors, and that makes the tunnels very hot. We've all been on the London Underground and experienced it being quite unpleasantly warm. I'm sure today's one an example. But it's then if you're using that energy, reusing some of that energy for the power of the train, it means actually your energy infrastructure when you build it has to be less, if you were building a metro system from scratch. So because you wouldn't need to be cooling all the air down there because you wouldn't be creating so much heat in the first place. So it's about a total energy efficiency piece, not just vehicle-based, but looking at the whole energy infrastructure required to develop something like a new metro system.
That's really quite amazing, really, actually. But also you do work for car companies. You've had that exciting project with Jaguar. Recently you announced you're working now with Nismo. Yes. Perhaps you could tell us about the Jaguar project first, please.
So with Jaguar, we developed CX-75. So it was a concept car from 2010 Paris Motor Show, and they had such a positive attitude and response, not just from the motoring press, but from the general public, that they wanted to put it into production or get to a prototype stage very quickly. And so we had already had some meetings with them about just in general, maybe there was something that we could do together, and this was something that we then decided to go ahead with. So we managed the whole programme, and it was a blended team of Jaguar and Williams engineers, and in it one of the particular pieces is the battery system. So it's probably one of the most sophisticated supercars ever designed, and is capable of being driven internal combustion engine only, electrically only, and combined is how you get the VMAX. So it's a pretty complicated system, because obviously you want the driver not to be necessarily aware of which element is powering his motion at any one time. So the sort of controls and finessing of it is very much a Jaguar based operation, as the interior trim and styling and some of the legal requirements, and then the materials, the hybrid system and the vehicle control module is all Williams technology.
Okay. Now, sadly, the project is no longer continuing, but presumably everything you've learnt from there is very applicable to any other car manufacturer who might want to go this route.
I think it's right to say that we're not going to make the 250 we initially said we were going to do, but the technology is being developed all the time, and you're going to see CX-75 appearing somewhere near you fairly shortly, and we've done a lot of demonstrations. So the technology works, and then we're using the basis of that technology to take into other models in the Jaguar range. That's something that we're looking at how we might apply it.
Wow, that's really exciting. And Nismo, presumably that's a wider program, or is it again your energy recovery systems that are being researched or worked on?
I think we're very excited that we've announced this relationship with Nismo at the British Grand Prix. Exactly the form of what we're going to be doing with them is not yet in the public domain, but I think clearly the skill set that we've displayed on something like CX-75 is one where we can definitely apply to other premium performance products, which is what the Nismo range of cars is.
Okay. Obviously, the advanced engineering side of Williams is something that's obviously growing. We're sitting here in the conference centre, but next door is a building being erected as we speak, Kirsty. So does that mean that the future for Williams F1 is very much involved with the advanced engineering side of the business?
Yes, it's two separate operations, obviously, but the reason that we are able to do what we can do in advanced engineering is we're taking people sometimes from Formula One and moving them across to advanced engineering, and also from low volume niche manufacturers and OEMs, and blending it together. But there are things that obviously where we learn on our side of the business we can feed back into to Formula One, but they do operate separately, so we're not draining any resource from the Formula One team, if you like. It's transfer of people should they wish to change the direction in their career, and vice versa. We've done the same in reverse, train people in advanced engineering, and then for the Formula One side want to use them to go racing.
Great. Kirsty Andrew for Racetech TV, thank you very much indeed. This is William Kimberley signing off. Thank you.